So the next thing we want to take a look at out of Unit 5-6, we're still working on proportional reasoning here, is we want to look at how you can solve word problems using proportions. So using that stuff that we did in the last lesson on setting up and solving proportions, we want to look at what we need to do when we're given a situation that's described to us in words and how we can solve for the unknown. So let's just start off a little discussion about situations that can involve proportions here. So the situation we're given here is that Beck is a registered nurse, and she uses a table like the one below to give the correct dose of a pain reliever. So the table shows their approximate body mass in kilograms and the dose of the pain reliever that they would give in milligrams. And we have some examples here. We've got, if the mass is 5 kilograms, the dose would be 60 milligrams. If the mass was 10 kilograms, the dose would be 120 milligrams, and so on and so on. And what we notice is that if we start from a body mass of 5 kilograms and we go to a body mass of 10 kilograms, we're essentially multiplying by 2. So the body mass is doubled. And what's happening to the dose when that happens? Well, we go from 60 to 120. The dose is also doubling. So when the body mass doubles, the dose also doubles. Now, when the body mass triples, well, if the body mass is tripling, then we're starting at 5, tripling it, multiplied by 3 to get 15. What's happening to the dose? Well, from 60 to 180 is also a factor of 3. So when the body mass triples, the dose also triples. So in this kind of a situation, when one thing that we're looking at doubles, the other thing doubles. When one triples, the other triples. If one would quadruple or be multiplied by 4, the other one would be multiplied by 4 as well. We can say that the drug dose are one variable and the body mass are proportional, or that the drug dose is proportional to the body mass, because we can write these things that we've had here as proportions. So for instance, if we take the first two entries in the table there, we could have written that 5 to 10, 5 to 60, okay, where this is our mass to our dose, is equal to 10 to 120. Where again, we have the ratio of mass to dose. And both of these are mass to dose. And we could use this information to sort of fill in the rest of the table. If we wanted to go up to mass of 20, well, that would be a factor of 4 from our original one, so this would be 240, also a factor of 4. If we wanted to go up to 25, well, that's 5 times 5, so we take our original dose here, 60, multiply it by 5, and get 300. And yes, at the bottom here I just said we can write the information from the table as proportions. Okay? And that's proportions of the form 5 to 60 equals 10 to 120, and so on, or mass to dose every time. Okay? Now let's look at a problem that we could be given based on a situation like this. Let's say we're told that we want to determine the drug dose for a body mass of 35 kilograms. We can do this using proportionals. First thing we're going to do is we're going to set up the ratio that we were given in the problem, and we're going to write it in words. And our ratio was that the dose was proportional to the mass. So the ratio that we want is mass to dose. Or, it's usually a lot more useful to write it as a fraction. So we'll write it as mass over dose. Okay. Step 2, we're going to write a let statement for the unknown. So what are we trying to find? Well, we're trying to find the dose for a body mass of 35 kilograms. So we'll just say let X be the dose for 35 kilograms. And now we want to set up the ratio that we're given here. So we always want to set it up using this ratio that we've written in words. So in words we had mass to dose. In the original question, we'll take out that equal sign. In the original question, our mass to dose ratio was a mass of 5 kilograms, gave us a dose of 60 milligrams. So we've gone from our ratio in words here to the ratio that we were given in the question. Okay. Step 4, write the second part of this proportion. So we're going to have another fraction over here, which is our second ratio, using the given information and the new variable. Well, what are we given? We're given a body mass of 35 kilograms. So what can we do with this number 35? Well, it represents a body mass, so it has to go up on the top of this proportion, okay? Because the top of the proportion is for the mass. Put the mass on top all the way along. What goes down here in this empty space? Well, we need something for the dose. The dose is what we're trying to find here, so we've let x be that unknown dose. So there is the proportion that we need to solve. And we can solve it using the skills that we learned in the last unit. That's step 5, solve the proportion. So we just want to cross multiply to get 5x equals, let's see, 60 times 35. We punch that into our calculator to 2100, and then divide both sides by 5. We get x equals 420. Okay. And if we really want to get fancy here, we can answer this question with a sentence here. The dose is 420 milligrams. And that just reminds whoever's ever reading this question that we understand what this x equals 420 means. It means it represents a dose, and we know that the units are in milligrams. So we've got a couple more examples on the back here. So let's work through this first one here together, and then for the third example, you could try that one on your own, and then check your answer with me. So the Toronto Raptors scored 9 3-point shots in the first 5 games of the 2011-2012 season. How many 3-pointers might the Raptors score in an 82-game season? First thing we want to figure out is what two quantities are being compared in our ratio. And what we're comparing here are, we're given 9 3-point shots, so we've got 3-point shots, and those 3-point shots were in the first 5 games. So we're looking at a ratio of 3-pointers, so I'll just say 3-point shots to games. Okay. What numbers were we given? Well, we were given for 3-pointers, we were given 9 3-pointers. Okay, so it goes up in the top with the 3-pointers. And how many games were we given? Well, 5 games. So 9 3-pointers in 5 games. Now, what are we asked to find here? How many 3-pointers might the Raptors score in an 82-game season? So that's our unknown. How many 3-pointers? So let's let x be number of 3-pointers in 82 games. Well, if x is the number of 3-pointers, in the second half of our proportion here, x has to go up on the top where we have 3-pointers, and 82 games has to go down on the bottom where we have the number of games. Now we just need to solve this proportion. We'll cross multiply, and we will get 5x on one side, and on the other side we get, see, 9 times 82, we punch this into our calculator, we get 738. Divide both sides by 5, and we get x equals 147.6. Okay. So since we can't have 0.6 of a 3-pointer, we're going to have to round this off. So we can do this in our concluding statement here. We can say, they would score, well, let's see, if we want 82 games, by the end of that 82nd game, they'll have scored 147 and then 0.6 of the 148th one. So they won't quite have made it up to 148. So we need to round down in this case. So we'll say 147 three-pointers. And there's our solution. So let's take a look at the next example here. Paige works in the summer picking apples. It took her 4 days to pick 9 rows of trees. How long will it take her to pick 20 rows of trees? Well, this is a good one to try on your own. So pause the video here, try this question, and then unpause it and check your solution with mine. So first off, let's identify what variables we have. We're given 4 days to pick 9 rows. So the quantities that are being related are days and rows. So let's set up our ratio here. Days and rows. Okay. What are we given in terms of numbers here? Well, we've got 4 days and 9 rows. And we want to come up with a second term in our ratio here. Well, let's see, what are we asked to find here? We're asked to find how long it will take her to pick 20 rows of trees. So how long is a length of time, or in this case, it'll be a number of days. So we can say, let x be number of days. Well, if x is a number of days, it has to go up on the top where the days are. And how many rows is that? What can we fill in for the number of rows here? Well, they tell us it's 20 rows. So that 20 has to go down on the bottom. Let's solve our proportion by cross multiplying. 9 times x is 9x. 4 times 20 is 80. And then we want to divide both sides by 9. We end up with x equals 8.88. So let's see. We want to conclude this. Obviously, we can't have 8.8 as for the days. We want to round this off to some even number of days. So let's see. By the end of the 8th day, she still has some more stuff to pick. When she gets 0.88 through that last day, she'll be finished. So we'll round this one up, and it will say it would take 9 days. Okay. And that's our solution.